Hello, everyone. Welcome to this week's episode of ClueCon Weekly. This week, joining us is an absolute authority in WebRTC. We've been worked together for a while, years ago. Tim Panton, founder and CTO at VoIP, a German company specializing in IoT, video, and other products. And I think, man, you have a resume that's very long, so I'll let Tim introduce himself.
Yeah, I mean, I guess the short way to say it is that I spent quite a lot of time in telephony many years ago, and did a little bit in the free switch world and built a few things. But in the end, I got kind of burnt out by honestly dealing with telecoms. But telcos are
Hmm.
just too annoying to deal with, and it was like I just couldn't do it anymore. So I strayed off into the IoT world and started building things in the IoT space, but leveraging what we'd learned in telecom. And about the first thing I did, I don't know if you can see it over my shoulder, that thing. That was about the first thing I did, and I had it built for me as a little thing to take to exhibition stands to demo stuff. But what's fun about it is you can control that over WebRTC. So I can change the color of it from my phone. Uh,
Oh, nice.
and and that's kind of, I mean, it's actually not showing up desperately well on the video, the color changes, because it
No, I
tends
can
to
see it.
wash out. But yeah, the point being that the low latency and the security that you get out of WebRTC is valuable in places other than video conferencing. Sure, you like for what we're doing now, you absolutely have to have both those things, and it's great. And we wouldn't have got through the pandemic in as good a state as we have without video conferencing working as well as it does. But what I found was that there's a bunch of other things you could do with the same benefits and technologies. And so, you know, that's what Pipe's set up to do. Pipe's set up to take the benefits of WebRTC and play with them in other spaces. And I'm particularly interested in IoT and in small devices. So, a typical small device is like one of these Raspberry Pis. And I guess the kind of meta theme of what I want to try and say today is that you can actually run really interesting WebRTC services on things of this scale and of this price. And we always sort of associate WebRTC with a big server and a chunky laptop and a good camera and all of that stuff. And sure, that's what you want for video conferencing. But some of the smaller stuff can actually do some really interesting things. And that's the sort of space that I kind of wanted to talk about.
Nice.
So I think a little sort of place maybe to start. Have you come across WIP?
Yeah, I have. I've been actually playing with Whip and looking at how to use it with First Switch, and it's an interesting protocol.
So is there a free switch gateway for WIP? Because that would be
Not yet. It's being worked on.
right. Okay, cool. So that would be really cool to do at some point. I kind of slightly backwards story this, but I ended up building what I think is probably my third WebRTC stack from the ground up
Oh,
um,
wow.
to implement WIP. So just a little backtrack so that to make clear what WIP is. WIP is like if you're someone like Twitch or YouTube or Tencent or somebody like that who has like creators sending live video to them, and then they want to distribute it out to a bunch of people. What you find is that the creators have to upload with a protocol that was out of date 15 years ago. So they either have to use RTMP or RTSP, and they're both like, how do I say this politely? Not modern. Okay,
Oh, yeah.
and but the bonus, the reason that they stick with them for the moment is that you can define them with a URL. So you can send your creator a URL, and they can put it into their camera or onto their laptop or into their phone, and that defines that link completely. And so they can then send live stream from a device of some sort up to the cloud, and then it gets distributed out. And the kind of WebRTC offer answer model really doesn't make that very easy for that ecosystem to work with. Like, it's too full of options and too full of back and forth and complex. And so what WIP is a standard that's kind of working its way through the IETF to try and define a URL for a very narrow WebRTC use case, which is essentially upload of a single video and a single audio stream to a server. And it turns out that if you take those simplifying assumptions that it's that simple a problem, that's all you want to do, then a whole bunch of the optionality that you've got in WebRTC just vanishes. You don't need to negotiate a whole ton of stuff because you know a lot of it. And so you can thin it down to, well, I think we could get further, but at the moment it's a single URL with a single round trip over that URL to set the thing up. And that's actually really cool. And for the beginning of this story is, I rather foolishly said in one of the meetings for the IETF, yeah, sure, I'll build a WIP client. Because one of the things we wanted to be sure about was that we were designing something that would run on devices of this scale. And so, the IETF way, and I really approve of this, is to do this is to build it and see if it works. So I ended up building a very simple, minimal WebRTC stack for doing WIP on a device like this. And it's now open source. I'll give you the URL in a minute. But it turned out to be really interesting because what you find is that these devices are perfectly capable of doing really good stuff. Now, I'm going to try and do a demo. I have no idea whether video over video over video is
dangerous demos and ClueCon Weekly. That's the best way to go about it.
Yeah, I'm not sure exactly how dangerous it is. At the moment,
it's video and video and video, so it's
yeah. So I should say that what you'll get is the quality of this won't be what it should be.
Of course.
Because
it's been recompressed.
It's been re-encoded several times. So what I'm going to send you, which way around should we do this? Let me show you first what let's do the whole screen. You're going to get the kind of Hall of Mirrors effect for a second, but that's how it goes, I'm afraid. So with any luck, you should have my whole screen. No, not yet. Let's try that again. Share the entire screen. Oh no, okay. No, that's not a good idea. Let's do this. Right. So what I'm going to show you is a viewer. So this is the kind of output of the thing. And I'm just trying to work out which way around to do this, but let me show you the output of this. So this is a content distribution system from Millicast. So I don't know if you can see the URL bar on it. No, you can't. Okay, cool. So this is a content distribution system from Millicast. And what I'm going to do is I'm going to send them a stream from a WebRTC enabled WIP device sitting on my desk. So with any luck, in this tab, we should get some video from me. There you go. So that is what you're seeing there is a PyCam on a Raspberry Pi 4, actually, doing 1080p at 30 frames a second in H.264. And so that's I don't know, $100.
Even with the rebroadcast, the quality is super good. It's really great.
Yeah, I mean, what I find is that I can actually defocus it so I don't look quite as old, which is great. But so this is and that what I haven't shown you is that was just basically starting the WIP client with a single URL. So I just sent it the URL, said, hey, go run this, and it it's set things off. And so that's actually kind of a lot simpler to get started with if you're a streamer or whatever, and you could build it into the hardware. So that's the kind of base case. And so I'd encourage two things. I'd encourage, and it sounds like you're already doing this, the folks at FreeSwitch and SignalWire to support WIP, because I think it's a really interesting
yeah, we're working on
simplification
on an internal broadcast platform project, which will include WIP for sure, because it's it's the way to go.
It's the obvious thing to do. Great, that's fantastic. And then the other thing I'd encourage the listeners to do is to go to github/pipe/whippy, that's WHIPI, which is the open source WebRTC stack, cut down WebRTC stack for doing this on Raspberry Pis. And what's interesting about that is that it doesn't need much CPU. So you'd think it encoding all that stuff would be hard work. Turns out that this class of device has an H.264 hardware encoder in it. So you don't have to worry about that. That's just like built into the camera hardware almost. And likewise, the ARM chips, almost all of the ARM chips have hardware accelerated AES. So the encryption of the video data is done like in a single instruction on ARM. And so it turns out that doing that is 10% of the CPU load on a $10 machine. So you can actually do it, which is kind of fun. So that's the sort of the message is that this stuff is possible on small devices, and it's actually not even that difficult. So I think that's the sort of big picture open source story. And then I thought it would be fun to maybe look at what that means if in a more kind of what's the word, kind of mobile environment where this thing is what we've got here is a two-wheel robot with a little caster wheel on it. So you've got two motors left and right, which can go run forwards and backwards. In the middle, there's a Raspberry Pi 3. So it's not even the kind of most modern Pi. And then a couple of batteries on the top. For the motors, I've got a 9-volt battery. And then for the Pi itself, there's a little 5-volt battery. So that's now at this instant. So what we have all you need on a device like this is, as I said, you've got the WebRTC capabilities for like H.264. So the other thing that you want to be able to do is to control the motors, and you want to try and do that over the data channel. So what we've done at Pipe, and this is different from actually, it's probably worth talking about that as well, because it's different from the previous example, which is very much client server, right? So effectively, you're uploading from a client device into a service, and the service is then rebroadcasting it, but it's a sort of very much a centralized architecture. Whereas with these things, I mean, one of the things that we do a lot of work on is security cameras and baby monitors. With them, you actually want to be able to keep working even if the even if the remote link isn't working. So you want to, like if AWS goes out, you still want to be able to hear your baby crying. You still want to monitor the security cameras down the hall. So if you've got you're on the local LAN, you want it to keep working. And so that's what we're enabling at Pipe. So the thing that's kind of the distinction of what we've done with Pipe and what we've done with WIP is WIP centralizes all the authentication. All the auth is done in the center. Whereas with Pipe, what we do is we push out the authentication to the edges. So the edge devices hold tokens, hold actually X509 keys that allow them to and manage them, allow them to validate each other without reference to a central service. And so that means that if the central service is out, then a pair of devices that have already talked to each other can carry on trusting each other for another session. And so that's actually really powerful in terms of kind of, the baby monitor or the video camera. But it's also fun with these devices, these mobile objects, because you want really low latency. And if you're on the same LAN, you certainly don't want it round tripping up through a server and back down again. So that's what these things do. And that's true for the video, but it's even more true for the motor control. When you click stop, you kind of want it to stop. So what we've done, and what I've spent quite a lot of time on recently, is trying to optimize that path so that you can get like as many layers out of it as possible. So like if you look at classic, you know, the libWebRTC strategy, there's like a pile of layers on top of each other. There's you know, a whole bunch of adaption stuff and buffers and, you know, a load of
most of it is
layers
geared towards making things work in bad conditions, which is the reverse of what you generally have on a local network. You're right.
Right, absolutely. But also work on a whole wide, wacky range of hardware. I mean, you know, the fact that WebRTC in the browser works on, you know, a cruddy laptop with a probably got a sound blaster in it, you know, whatever. All of that's kind of antique stuff, and it also works on the most modern whatever. It is to do with the fact that there's just like piles of layers rate adapting and doing stuff. Whereas with this thing, you know exactly what's in there. I know what this codec is capable of. I know what the hardware is. And so what you can do is you can thin down the WebRTC layer and just basically expose the hardware almost directly. And in the case of the GPIO and the motors on this, I've literally done that. In the file system, they appear in the file system in sys class, and I just export them over a WebRTC data channel. And so in the browser, you can write to what looks like, you know, a WebSocket effectively, but it's actually a WebRTC data channel. And when you write to it, at the far end, it writes to the sys file system and changes the state of the pins. And so you've got like as few layers as possible between you clicking the button on the interface and something happening at the far end. And so that gives you quite a responsive thing to drive. And that's a very different style of kind of WebRTC use. And I guess that's the big, you know, conceptual thing with pipe is to say, okay, we're going to reuse the protocol, but the way that we build it and the way that we, you know, deploy it and think about how it's built is very much tuned to the circumstances. So what we've got here is a WebRTC browser connecting to that little robot, and this is, you can see the bit rate, and it's H.264, and I can drive it. I can drive it around using the arrow keys, and it's, what you'll notice is if I drive it off to the far edge of the room, which is as far away from the Wi-Fi router as possible, the bit rate may actually start to drop, and as I get closer, it may get higher. So we're doing adaptive bit rate management here in the true WebRTC style.
Doesn't look bad at all.
Amusingly, I'm really pleased with the results, to be quite honest. But amusingly, you can do it again through the file system, through the Linux file system, or rather through V4L2 control. So you can adjust the bit rate of the encoder actually on the command line of in the shell, which is kind of fun. So now what we're going to do is I'm going to lend you access to that. So if you scan that QR code,
let me remove myself from that area. Somewhere. Let me remove myself from that area on the screen, and I'll go grab the QR code. Okay, dev pipe. Loading up on.
So you can see that they're doing a full X509 key exchange mediated by me because I trust you and it trusts me. And now at some point you should get access to that. It should load a screen for you.
It's saying borrow access to device.
Yeah, and you should in a second should connect. I'm going to reload that page. It should, I would think it would be there, but try again.
So it's asking me to borrow access to a device. Black screen with that. Connected to friend's phone?
Well, so let's just give it, let me give you a new QR code and we'll try that
Sure.
one. Try that.
Looks more or less the same as before.
So give it a second. It's doing a key exchange.
Oh, there we go. Yeah.
Okay, good.
Yeah, there's
So
also
if
something
you've
with
got that, I can also,
candidates, video state.
you can both view the same thing. So now you're
Um,
driving and we can
yeah.
watch it. And the fun thing here is that we're negotiating down to the lowest bit rate of the two of us. If you press both at once, you'll go forwards.
Oh, okay. So there's the
Yep.
I want to do this all day now.
Well, right. So that was actually my ask, which is that I think we should try and figure out some way to make this a ClueCon thing. It feels like the sort of thing we should be doing at ClueCon is racing these or building these or doing something.
Let's race these. I mean, the easiest way is just to build out. We've done something similar, much less technologically advanced with robots before, where we had built a circuit. Why don't we build out a circuit for these and then have people run them? We couldn't even do a tournament.
Right, exactly. So and what's kind of weird about this is, and it's reasonably
awesome.
responsive. You're like 5,000 miles away, but it's still pretty good. And actually, we're kind of running like 3 layered videos over this. Like I'm sharing my screen, and like there's just
for the
a
people
load of stuff
we're
going
watching, I'm pressing left now. I mean, it's I can drive this all day without any problems. Like I could actually accomplish a task if I had to. So
right. I
lag
reckon
is
you could get. I mean, if you turn to your left,
yeah.
keep going, and you'll see a doorway. I think the interesting test is whether you can steer your way through the doorway.
Let's see if I can get there. Boom.
Yeah. Okay. Now you've run into the door. Right now, interesting. You don't have a reverse button, but I do. So I shall move you backwards. Now try again. Yeah.
Just a little bit to the left, and there we go. We're outside.
Yeah, exactly.
I'm free.
You're free. You're free. So I mean, it's kind of interesting and the quality is, it's negotiated down to 800 kilobits a second, but that's like it's perfectly usable, and you can just see my feet.
Oh yeah, it's absolutely usable, considering I'm actually watching the video on the broadcast, which is a few milliseconds behind, of course.
Oh, really? Okay, so you're not watching it on your phone.
Yeah, I was driving on a larger screen is easier.
Oh, okay, cool.
It's awesome.
Right. Well,
thank you so much.
So I'll kill the share, and we'll drop back into chat mode. So I'm frustrated that I was unable to show you the code, but maybe that's the subject of a ClueCon talk instead.
Why not? Yeah.
But so the message here is that these small devices are perfectly capable of producing good quality, variable bit rate WebRTC streams for ingest into like big services, or for driving little robots, or for monitoring your baby. And that kind of whole niche or set of niches of applications that aren't traditional WebRTC platforms are available. And the that kind of privacy, data channel, all of those nice features really fit well into the IoT space. And I kind of, that's the message I'm trying to get over. And the final thing is that WebRTC doesn't have to be libWebRTC. Like, there are a ton of other implementations of WebRTC. I mean, I've got a couple.
Oh, yeah.
There are a ton of others out there. And actually, like, if you're doing a WebRTC project, you should think about what is the right stack for you. What platform are you going to run on, and pick a stack that works in that platform and has that set of optimizations. Because for anything outside the browser, libWebRTC is probably the wrong answer.
Oh, is it?
So libWebRTC
I've seen a lot of other clients using WebRTC, using libWebRTC as the de facto way of doing things. I was even using a node binding to libWebRTC to do some headless testing, actually.
Yeah, the trouble is that it's just got a ton of assumptions that it's, that it doesn't need. Like I said, all of those layers and all of the kind of overhead of the memory management and all of that stuff that, I mean, the other thing I was going to show you is that the footprint on the Raspberry Pi is really small of this code. It doesn't have to be big to do this. Like 10 megabyte binary is, and I know that sounds big but it's actually, that's all you need. Whereas, the libWebRTC is like 20 gigs to build. Admittedly, the binary that comes out isn't quite that big, but it's still huge. And so, I would emphasize that there are other stacks out there that may fit your use case much better than libWebRTC. And that wasn't true 5 years ago. Like, one of the things that's changed in the last few years is that people have built more implementations of the protocol, SignalWire included. And I think that's a big change. And I think people need to kind of review their assumption that libWebRTC is the only answer, because it just isn't anymore. There are plenty of others now.
There's there are at least a couple open source complete implementations. One is Pion, that Go WebRTC library that's actually completely grounds up, and I think most of the services I know, like Janus, also doesn't use libWebRTC as far as I know. We should check with Lorenzo. We can just go.
Yeah. So I mean, I think I don't think Janus uses libWebRTC, and I think that MediaSoup is moving away from libWebRTC. I think there's still a little bit they use for congestion control or something.
Which is actually one of the hardest parts, to be fair. So there's some use case there, like.
Yeah, sure. Although, I mean, if that's now in Pion, I think they've now got at least they've got loss-based congestion control. I'm not sure if they've got the. Actually, we should, if we've still got a minute, I've got a little rant about this. Right. So the thing with what WebRTC does about bandwidth management is just frankly magic. Okay, it is and if you've never looked into it, it's like, I hadn't until a couple of years ago, and I suddenly realized how cool it was. So, like, your traditional TCP thing is you say, well, you keep sending more and more until you start seeing losses, and then you back off a bit. That's how TCP manages, finds out how much capacity it's got, and then it will just like kind of bounce up and down along that line. The trouble is that there are losses, and that's in video, losing a packet is quite expensive, because you may lose a whole frame, and if you're unlucky, that's a key frame, and then it's unfortunate. So what WebRTC does is it does the loss-based stuff, but it also does a thing where it looks at the packet arrival time, and it makes the observation that if you're just approaching the congestion level of a path, then something in that path will start to buffer. Like either your local router or uplink somewhere or wherever, there'll be a little bit of buffering will start to happen. And what WebRTC does is it watches the differential timing, and it spots that buffering just as it's occurring. And if you back off quickly enough, you can come in under the congestion layer. You can come in
Right.
without losing any packets because you spotted it happening. And so what you'll see a good WebRTC implementation doing is surfing just under the congestion layer. And that's by watching the timing. It doesn't always work. And, there are issues, there can be issues with various other things like something else crowding out on the Wi-Fi or whatever, and then it can't guess that. But just that kind of predictive thing by looking at the timing is amazing. And the fact that it works as well as it does is just fantastic. And I think that is also relatively new, getting that like really solid. I know we've implemented the uplink part of that for piping here. And that's why you saw that bandwidth changing as I moved around the room, is because it could detect that it was getting better and worse link quality there. So yeah, a little rant about congestion control in WebRTC. I think
congestion
it's just
control
magic.
is not just about the congestion itself; it's about better quality too. There's a lot of discussion around how to handle congestion, and there's I think we could go. There's almost at least a ClueCon talk just in congestion in there
Sure.
somewhere.
And deciding what's the best use of what you've got, like, is use case dependent, right? So there are things where you'd rather drop the frame rate but keep the quality, and there are other things where, like driving that thing, where you need to keep the frame rate, and if you drop a bit of quality, well, people will probably live with it. And so there's a different set of trade-offs, and on that thing there's no audio, so you don't care. But in this, you want to absolutely make sure that the audio comes through, and if I get slightly pixelated, well, it'll be a shame, but it doesn't matter. But you want to be able to hear what I'm saying. So there's that set of optimizations varies from use case to use case, which I think is a really interesting engineering challenge.
Plus, it varies from person to person. I know people would prefer lower frame rate and higher quality. I prefer higher frame rate and lower quality if you make me choose. So there's it's not even a objective thing. It's very subjective. Like what constitutes definition of quality is never the same.
Right. And it may depend on things like whether you lit read and what your cultural background is, how interested you are in gestures and watching facial expressions. You may have a different set of criteria for that than other people. So it's a really well, I'm sure there are a ton of PhDs written on it, and if there aren't, there should be.
Wow, that's true. Yeah, this is it's kind of like how the Moss score is a very good approximation, but it's not the end all be all. You still want to be aware of many other things in telephony. So that same thing goes for quality for sure, for video quality for sure. Well, thank you, Tim. It's been great. I mean, I had never driven a robot on ClueCon Weekly, so that's the first. So, guys,
well, and from like 1,000 miles away as well.
This is the kind of thing you can do with WebRTC. This kind of thing we can build out open source tools and protocols and knowledge. So go forth and build more robots, and we'll have a robot race at ClueCon for sure. Let's do that. It needs right. At this point, it just needs to happen. There's no way around it.
Yeah, it's got to happen. I'll drop you the URL for the WIPI GitHub so that people can have a play with that and hopefully put in PRs and improve it. That'd be most welcome.
And we'll put that in the video description.
Brilliant.
Cool. So, well, thank you. Today's guest was Tim Panton, co-founder and CTO and Pipe and WebRTC Authority, and it was very fun for me, and I hope it was very fun for the audience too. Thank you, Tim.